have Boyle's law, Charles' law, Avogadro's.
Clear that the atomic mass of oxygen is 16, the atomic mass of carbon is 12, nitrogen is 14, like that. There are some other situations in which we have to express these atomic masses in specific units. For example, when the atomic mass is expressed in gram, we may simply call it as gram atomic mass. That means mass in gram that's equal to the atomic mass of an element. For example, in case of oxygen, atomic mass is 16. So 16 gram represents the gram atomic mass of oxygen. Atomic mass of carbon is 12. 12 gram of carbon represents gram atomic mass of carbon. Similarly, I will say one more example. The atomic mass of nitrogen is 14. So, the gram atomic mass of nitrogen is 14 gram. Or in other words, this 14 gram of nitrogen represents 1 gram atomic mass of nitrogen. See, 16 gram of oxygen is the 16 gram is the gram atomic mass of oxygen. Or we can say 16 gram oxygen represents 1 gram atomic mass of oxygen, or simply 1 GAM. Okay, so 16 gram oxygen represents 1 gram atomic mass, or simply 1 GAM. 12 gram carbon represents 1 gram atomic mass of carbon, or simply 1 GAM. See, 1 GAM of carbon is 12 gram. The gram atomic mass of carbon is 12 gram. 12 gram represents 1 GAM of carbon. 16 gram represents the gram atomic mass of oxygen, or 1 GAM of oxygen is 16 gram, like that. 1 GAM of any element contains Avogadro number of atoms. For example, 16 gram of oxygen represents 1 gram atomic mass of oxygen. That's 16 gram of oxygen is 1 GAM of oxygen. This 1 GAM of oxygen contains 6.022 into 10 raised to 23 atoms. 12 gram carbon is 1 GAM of carbon. That 12 gram carbon, that means 1 GAM of carbon, contains 6.022 into 10 raised to 23 Avogadro number of atoms. Similarly, 14 gram nitrogen, that represents 1 GAM of nitrogen, that contains Avogadro number of atoms. See now, 16 gram of oxygen is 1 GAM. 1 GAM contains 1 into 6.022 into 10 raised to 23 atoms. So, 32 gram represents, see, 16 gram is 1 GAM. So, 32 gram will be how many? Yes, 2 GAM. So, 2 GAM will contains, yes, 2 into 6.022 into 10 raised to 23 atoms. Now listen, 48 gram of oxygen. 16 gram is 1 GAM. So 48 gram will be 48 divided by 16. That is equal to 3. So 14 gram oxygen represents 3 GAM of oxygen. So that will contain 3 into 6.022 into 10 raised to 23 atoms. Let's take another example. 14 gram nitrogen represents 1 GAM, and that 1 GAM contains Avogadro number of atoms, 6.022 into 10 raised to 23 atoms. 28 gram of nitrogen will be 28 gram divided by 14, mass given divided by gram atomic mass, that's equal to 2. So 28 gram of nitrogen, 2 GAM. That 2 GAM will contain 2 into 6.022 into 10 raised to 23 atoms. Similarly, in case of carbon, 12 gram carbon represents 1 GAM. Suppose we are taking 120 gram of carbon, then 120 by 12. Mass given in gram divided by gram atomic mass, that's equal to 10. So 120 gram represents 10 GAM of carbon, and that 10 GAM will contain 10 into Avogadro number of atoms. Clear? So very simple logic. 16 gram oxygen, 1 GAM. 1 GAM contains 6.022 into 10 raised to 23 atoms. 32 gram will contain 2 GAM. 2 GAM will contain 6.022 into 10 raised to 23 into 2. That much number of atoms. Now, 3 GAM of oxygen. 1 GAM is 16 gram. So 3 GAM will be 3 into 16. That's equal to 48 gram. Similarly, see, 14 gram is the gram atomic mass of nitrogen. 1 GAM of nitrogen, 14 gram. 28 gram nitrogen will be 2 GAM. 10 GAM of nitrogen will be 10 into 14 gram. That's equal to 140 gram. So 140 gram nitrogen. That means 10 GAM. 10 GAM is equivalent to 10 into 6.022 into 10 raised to 23 atoms. So all are connected with each other. 1 GAM, 6.022 into 10 raised to 23 atoms, gram atomic mass. In the free state, elements and compounds exist as molecules. Mass of a given molecule, molecular mass, that can be calculated from the given atomic masses of the constituent elements of the molecule. For example, let's take a diatomic molecule, oxygen. Oxygen is O2. It contains 2 atoms of oxygen. We had already studied that the atomic mass of oxygen is 16. So oxygen molecule contains 2 oxygen atoms. So 16 into 2. So 32 is the molecular mass of oxygen. Similarly, let us take another example. The molecular mass of water, how can be calculated? The chemical formula of water is H2O. It contains 2 hydrogen atoms plus 1 oxygen atom. The atomic mass of hydrogen is 1. So 1 into 2 plus the atomic mass of oxygen is 16. 16 into 1. So 1 into 2 plus 16 into 1. 2 plus 16. That's equal to 18. So 18 is the molecular mass of water. See, molecular mass expressed in gram is called gram molecular mass. Mass in gram, that's equal to the molecular mass of a given substance. For example, the molecular mass of water is 18. Its gram molecular mass will be 18 gram. Molecular mass of oxygen is 32. Its gram molecular mass will be 32 gram. See, 32 gram oxygen represents the gram molecular mass of oxygen. Or simply we can say 32 gram oxygen represents 1 gram molecular mass. Very simply we can say 1 GMM of oxygen. Similarly, 18 gram of water, that represents the gram molecular mass of water. That 18 gram represents 1 GMM of water. Similarly, see the molecular mass of carbon dioxide. If you are calculating by using the methods that I had already told you, you will get the molecular mass of carbon dioxide as 44. That 44 gram of carbon dioxide, that represents 1 GMM of carbon dioxide. So 18 gram water, 1 GMM of water. 32 gram oxygen, 1 GMM of oxygen. 44 gram carbon dioxide, 1 GMM of carbon dioxide. And more to that, see, 1 GMM of every substance contains Avogadro number of molecules. That means 32 gram oxygen will contain 6.022 into 10 raised to 23 number of molecules. 18 gram water will contain 6.022 into 10 raised to 23 number of molecules. Similarly, 44 gram carbon dioxide will contain 6.022 into 10 raised to 23 molecules. So we can discuss other topics in the next class, the remaining topics in the next class.